Hello, in this lecture we will answer on two questions. The first question is to find out the diameter of this orange circle, and the second question is to find out the size of this angle theta. So we'll start with the first question. In the drawing we have three semicircles. The two smaller semicircles are contained by the biggest semicircle, and inside the biggest semicircle we have also the orange circle, and we know that the radius of this small semicircle is actually equals to 10 over 2, that is 5 units, and the radius of this semicircle is equal to the diameter over 2, that is 20 over 2, it is 10 units, and the radius of the biggest semicircle, it is equal to the diameter of the semicircle over 2. The diameter is 30. 30 over 2 is 15 units. So the diameter of the biggest semicircle is equal to 15 units. The diameter of this semicircle is equal to 10 units, and the diameter of this the radius of this semicircle is equal to 10 units, and the radius of the smallest semicircle is equal to 5 units. And we want to find out the diameter of this orange circle. So we will define the radius of this orange circle as R. I'll write it down. So R is the radius of the orange circle, and we will define the center of the orange circle as C. So this is the center, and we'll define the center of the orange circle as C. Then we will define the center of the smallest semicircle, this semicircle, as X. We will define the center of the biggest semicircle as Y, and we'll define the center of this semicircle as Z. In the next step, we will join together all the centers of the semicircles in the center of the orange circle that is located at this point C. And I will present to you two new rules that are connected to two circles that are tangent to each other. That is to say, if two circles touch each other at one point, then there is two types of tendency between two circles. The first type of tendency is the external lunge. In this case, those two circles are touching each other at this point. This is the point of tendency between those two circles. And we also know that the center of the small circle is at point M, and the radius of this small circle is equal to small r, while the center of the big semicircle is at this point, point O, and the radius of the big circle is capital R. So what is the distance between the centers of the two circles whenever you have an external launch between two circles, like in this drawing? Then the distance between the centers of the circles will be equal to the sum of the lengths of the radii. That is to say, it will be equal to the length of the radius of this circle, that is r, plus the length of the radius of this circle, that is capital R. That is to say, the distance between the centers will be equal to capital R plus small r. So whenever there is an internal launch, an external launch between two circles, then the distance between their centers will be equal to the sum of the lengths of their radii. In this case, it is capital R plus small r. So this is the external launch, and we have another type of tangency between two circles. That is to say, two circles can touch each other also internally, and this is the internal launch. Those two circles are touching each other internally at this point. This is the point of tendency between those two circles, and the distance between their centers, that is to say, the length of line segment MO, will be equal to the difference between the lengths of their radii. In this case, it will be equal to capital R minus small r. And from the drawing, you can see that capital R minus small r is equal exactly to MO, that is the distance between the centers of those two circles. Okay, so we use those two new rules in order to calculate the values of the line segments in this drawing. So, what is the length of line segment CX? C is the center of the orange circle with radius R, and X is the center of this semicircle with radius 5. Those two circle and semicircle have an external launch between them at this point. This is the point of tendency between them. Therefore, the distance between their centers will be equal to the sum of the lengths of their radii. That is to say, it will be equal to the radius of the orange circle, that is R, plus the radius of the small semicircle, this small semicircle, that is 5. So in conclusion, we found out that CX, the length of line segment CX, is equal to R plus 5 Likewise, we will calculate the length of line segment CY. And repeat again that C is the center of the orange circle with radius R. Y is the center of the biggest semicircle with radius 15. The orange circle and the biggest semicircle have an internal launch between them at this point. That is to say, they are touching each other internally at this point. And whenever two circles are touching each other internally, then the distance between their centers will be equal to the difference between the length of their radii. The radius of the biggest circle is 15. the radius of the orange circle is equal to r, and the difference between those two radii is 15 minus r. So in conclusion, we found out that Cy equals to 15 minus r units. Likewise, we'll calculate the value of line segment CZ. I will repeat again that C is the center of the orange circle with radius r. Z is the center of this semicircle with radius 10. Those circle and semicircle have an external notch between them at this point. That is to say, they are touching each other externally at this point. This is the point of tendency between the semicircle and the circle. Therefore, whenever you have an external notch between two circles or semicircles, then the distance between their centers will be equal to the sum of the length of the radii. That is to say, it will be equal to the radius of this circle, that is r, plus the radius of this semicircle, that is 10. In conclusion, we found out that line segment CZ is equal to r plus 10. Okay, CZ equals to r plus 10. Likewise, we will calculate the value of line segment XY. The value of line segment XY X is the center of this semicircle with radius 5. Y is the center of the biggest semicircle with radius 15. The smallest semicircle and the biggest semicircle have an internal notch between them at this point. That is to say, at point A. They are touching each other internally. And whenever you have two circles that have an internal notch between them, then the distance between their centers, that is to say, the length of line segment XY, will be equal to the difference between the lengths of the radii. And the radius of the biggest circle is equal to 15 units. The radius of the smallest semicircle equals to 5 units, and the difference between those two radii is 15 minus 5, it is 10. So we found out that xy equals to 10 units. xy equals to 10 units. And likewise, we calculate the value of line segment xz. X is the center of the smallest semicircle with radius 5. Z is the center of this semicircle with radius 10. Those two semicircles have an external notch between them at this point, point P, that is to say, they are touching each other externally at point P. Therefore, the distance between their centers will be equal to the sum of the length of the radii. Sum of the lengths of the radii. So, that is to say, it will be equal to the radius of this semicircle, that is 10, plus the radius of this semicircle, that is 5. 10 plus 5 is 15. So in conclusion, we found out that the size of the length of line segment XZ equals to 15 units. Okay? In the next step, I will present to you a new law, which is actually the law of cosines. The law of cosines is true in any triangle. So if we have triangle ABC, that could be any triangle. This is triangle ABC. And we know that side AB of triangle ABC equals to A units in its length, side BC of triangle ABC equals to B units in its length, and side AC equals to C units in its length. And we also know that the angle between side AB and side BC is angle theta. Then according to the law of cosines, we will get that C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Okay? I repeat again that the law of sines can be used for any triangle, and actually the Pythagoras theorem is a special case of the law of cosines when angle theta equals to 90 degrees. When angle theta is equal to 90 degrees, then triangle ABC is a right triangle. And in this equation, we'll get that theta is equal to 90 degrees, so cosine 90 degrees is 0. 0 times anything is still will be equal to 0, so 2 times 0 is 0. 2 times AB times 0 is 0. So this expression minus 2 times AB times cosine 90 degrees will be equal to 0. And we're left only with C squared, that is equal to A squared plus B squared. And this is exactly the Pythagoras theorem that says that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in conclusion, the Pythagoras theorem is a special case of the law of cosines when angle theta equals to 90 degrees, and then we are talking on a right triangle. Okay, so we will implement this law, the law of cosines, in our triangle XCY or CXY. So I will copy triangle CXY in a new page, and we will implement the law of cosines in this triangle XCY. So this is triangle CXY that I copied from the original drawing. We have already found out that line segment CX equals to 5R plus 5. We already found out that XY equals to 10 units. And we have already found out that line segment CY equals to 15 minus R. So we'll implement the law of cosines in this triangle CXY. We'll get that according to the law of cosines, this will be equation number 1. cy squared is equal to cx squared plus xy squared minus 2 times cx cy times cosine theta. Okay, this is the implementation. Equation number 1 is the implementation of the law of cosines on this triangle cxy. Okay, in the next step we will substitute cy by 15 minus r, we'll substitute cx by r plus 5, and we'll substitute xy by 10. We'll do it now, and we'll get that according to equation number 1, cy is 15 minus r, so cy squared will be equal to 15 minus r squared, and it is equal to cx squared. Cx is r plus 5, therefore cx squared will be equal to r plus 5 squared plus xy squared. Xy equals to 10, so xy squared is 10 squared, that is 100. Minus 2 times cx. Cx is r plus 5 times cy is 10 times cosine theta. Here we will open the brackets on both sides of equation number 1, and we will get that according to equation number 1, 15 minus r squared equals to 15 squared, that is 225, plus r squared minus 2 times 15 times r is minus 30r, and it is equal to r plus 5 squared, and r plus 5 squared equals to r squared plus 5 squared, that is 25, plus 2 times r times 5 is 10r, plus 100 minus 2 times 10 is minus 20 times r plus 5 times cosine theta. So here we have r squared on both sides of the equation, so r squared will get cancelled. What is left from equation number 1 after we cancelled r squared? What is left is actually in this side. What is left is actually 225 plus minus 30r, and in the other side of the equation we have 25 plus 100 is 125 plus 10r minus 20 times r plus 5 times cosine theta. Here we will subtract 125 from this equation, and we'll get that 225 minus 125 is 100. We'll subtract 10r from this equation, equation number 1, and we'll get that minus 30r minus 10r is minus 40r. And in this side of the equation we left only with minus 20 times r plus 5 times cosine theta. Here we will multiply equation number 1 by minus 1, and we'll get that according to equation number 1, minus 40r times minus 1 is plus 40r, minus 1 times 100 is minus 100, and it is equal to minus 1 times minus 20 is plus 20 times r plus 5 times cosine theta. Here we will divide equation number 1 by 20 times r plus 5, and we get that cosine theta, according to equation number 1, is equal to 40r minus 100 over 20 times r plus 5. Okay, so I'll repeat again. Here cosine theta equals to 40r minus 100 over 20 times r plus 5. So here we will divide both the numerator and the denominator of this equation, on this side of equation number 1, by 20, and we will get that 40r over 20 is 2r, minus 100 over 20, minus 100 over 20 is minus 5, over 20 over 20 is 1, so in the denominator we left only with r plus 5. So in conclusion, we found out that according to equation number 1, cosine theta equals to 2r minus 5 over r plus 5. Okay, we found out that cosine theta equals to 2r minus 5 over r plus 5. In the next step, we will implement the law of cosines on triangle XCZ. So I will copy triangle XCZ in a new page, and we will implement the law of cosines in this triangle CXZ. We have already found out that Cx equals to r plus 5. Xz is equal to 15. And Cx is equal to r plus 10. So we will implement the law of cosines in this triangle CXZ. This will be equation number 2. According to the law of cosines, we will get that CZ squared equals to CX squared CX squared plus XZ squared minus 2 times CX times XZ. Okay, minus 2 times CX times XZ times cosine theta. So according to equation number 2, cz squared, cz is r plus 10, so cz squared will be equal to r plus 10 squared, and it is equal to cx squared. Cx equals to 15, so cx squared is 15 squared, 15 squared is 225, and so this is xz squared, that is 15 squared, that is equal to 225 plus cx squared. Cx is r plus 5, so cx squared will be equal to r plus 5 squared minus 2 times cx is r plus 5 times xz, that is 15, times cosine theta. Here we will open the brackets on both sides of equation number 2, and we get that r plus 10 squared, it is equal to r squared plus 10 squared is 100, plus 2 times r times 10 is 20r, and it is equal to 225 plus r plus 5 squared is r squared plus 5 squared, that is 25, plus 2 times r plus 5 is plus 10r, minus 2 times 15 is minus 30 times r plus 5 times cosine theta. So here we have r squared on both sides of equation number 2, so r squared will get cancelled. What is left from equation number 2 after we cancelled r squared? What is left is actually in this side we have 100 plus 20r, and we have 100 plus 20r, according to equation number 2. In this side of the equation we have 100 plus 20r, and it is equal to 225 plus 25 is 250, and we have also plus 10r minus 30 times r plus 5 times cosine theta. Okay. So we will subtract 250 from this equation, equation number 2, and we will get that 100 minus 250 is minus 150. We will subtract 10r from this equation, equation number 2, and we will get that 20r minus minus 10r is 10r. And it is equal to minus 30 times r plus 5 times cosine theta. Here we will multiply equation number 1, we will multiply equation number 2 by minus 1, and we get that according to equation number 2, minus 150 times minus 1 is plus 150, and 10r minus 1 is minus 10r, and it is equal to minus 30 times minus 1 is plus 30 times r plus 5 times cosine theta. Okay, we divide equation number 2 by 30 times r plus 5, and we get that according to equation number 2, cosine theta is equal to 150 minus 10r over 30 times r plus 5. Here we will divide both the numerator and the denominator of this side of equation number 2 by 30, and we will get that 150 we will divide equation both the numerator and the denominator of this side of equation number 2 by 10, and we will get that 150 by 10 is 15, minus 10r over 10 is minus r, over 30 over 10 is 3, okay, so we found out that according to equation number 2, cosine theta is equal to 15 minus r over 3 times r plus 5. Okay. So, according to equation number 2, cosine theta equals to 15 minus r over 3 times r plus 5. But according to equation number 1, we have already found out that cosine theta is equal to 2r minus 5 over r plus 5. So we create equation number 3 that states that cosine theta according to equation number 1 must be equal to cosine theta according to equation number 2. Okay, so equation number 3 states that cosine theta according to equation number 1, that is actually 2r minus 5 over r plus 5, must be equal to cosine theta according to equation number 2. That is actually 15 minus r 15 minus r over 3 times r plus 5 . Here we will multiply equation number 3 by r plus 5. So r plus 5 will get cancelled from the denominator of equation number 3. And then we will multiply equation number 3. So r plus 5 will get cancelled from the denominator. Here we multiply equation number 3 by 3. And we will get that according to equation number 3, 3 times 2r minus 5 is equal to 15 minus r. We will open the brackets on this side of equation number 3, and we will get that 3 times 2r is 6r, 3 times minus 5 is minus 15, and it is equal to 15 minus r. Here we will add to equation number 3 r, and we will also add 15, and we get that according to equation number 3, 6r plus r is 7r. And 15 plus 15 is 30. So in conclusion, we found out that according to equation number 3, 7r equals to 30. We divide equation number 3 by 7, and we get that the radius of the orange circle is equal to 30 over 7 units. But we are looking for the diameter that is twice as large as the radius, so we will multiply the radius by 2 and we will get the diameter. So can I write down that the diameter of the orange circle is equal to 2r, that is actually 2 times r is 30 over 7, that is equal to 60 over 7 units. So the diameter of the orange circle is equal to either 60 over 7 units, or in terms of numbers, we get that the diameter of the orange circle equals to 8.5714 units. Okay, we finished to answer on question number 1. In the next step, I will summarize the lecture. Okay, so we actually wanted to find out the diameter of this orange circle, and we have in the drawing 3 semicircles. 2 semicircles are located inside the big semicircle, and inside the biggest semicircle we have also the orange circle. And we know that the radius of this semicircle is 5 units, the radius of this semicircle is 10 units, and the radius of the biggest semicircle, this semicircle, is 15 units. And we want to find out the diameter of this orange circle. So we defined the center of this open circle is C, and we also defined the radius of this open circle as R. We defined the center of the smallest semicircle as X, we defined the center of the biggest semicircle as Y, and we defined the center of this semicircle as Z. Okay, then actually, in order to find out the segment lines of the values or the lengths of all the segment lines in the drawing, I presented to you two new rules in relation to two circles that are touching each other at one point, two circles that are tangent to each other. We have two types of tangency. Either it can be the external lunge. This is the example of the external lunge. Those two circles are touching each other externally at this point. So this is the point of tangency between the two circles. And in this case, the distance between the centers of those two circles will be equal to the sum of the lengths of their radii. This is to say, it will be equal to small r plus capital R. And we also have a second type of tendency between two circles. When two circles are touching each other internally, like in this drawing, those two circles are touching each other internally at this point, then we are talking about the internal lunge. And the distance between the centers of two circles, when you have the internal lunge between them, it will be equal to the difference between the lengths of the radii. Okay, in this case, it will be equal to capital R minus small r. Okay, so we have two types of tendency between two circles. The first type is the external lunge, and then the distance between the centers of the two circles will be equal to the sum of the lengths of the radii. In this case, it is capital R plus small r. And we have also the internal lunge, when the two circles are touching each other internally. Then it is defined as the internal lunge, and the distance between the centers will be equal to the difference between the lengths of their radii. In this case, it is capital R minus small r. Implemented the two new rules in our drawing. Here we calculated the length of line segment CX, but before that we defined the center of the open circle as R, and we defined the center of the open circle as C, and the radius of the open circle is equal to R, according to our definition. So what is the length of line segment CX? The length of line segment CX is, again, C is the center of the open circle with radius R, X is the center of this semicircle with radius 5. Those two circles and semicircle have an external lunge between them at this point, that is to say they are touching each other externally at this point. Therefore, the distance between their centers will be equal to the sum of the lengths of their radii. So, and we know that the radius of this open circle is equal to R, the radius of this semicircle is equal to 5, and the sum of those two radii equals to R plus 5. So Cx equals to R plus 5. Likewise, we calculated the value of line segment Cy. C is the center of this semicircle, the open semicircle with radius R. Y is the center of the biggest semicircle with radius 15. And the biggest semicircle and the orange circle have an internal notch between them at this point, that is to say they are touching each other internally at this point. This is the point of tendency, and whenever we have an internal notch between two circles, then the distance between the centers will be equal to the difference between the lengths of the radii. The radius of the biggest circle is 15 units, the radius of the orange circle is r, and the difference between the radii is 15 minus r. So we found out that cy equals to 15 minus r. Likewise, we calculated the value of line segment CZ. C is the center of the orange circle with radius r. Z is the center of this semicircle with radius 10, and the distance between their centers, that is to say the length of line segment CZ. Actually, those two, the orange circle and this semicircle, have an external notch between them at this point. That is to say they are touching each other externally at this point. And whenever you have two circles that are touching each other externally, then the distance between their centers will be equal to the sum of the lengths of the radii. That is to say, it will be equal to the radius of this semicircle, that is r, plus the radius of this semicircle, that is 10. In conclusion, we found out that CZ equals to r plus 10. Okay. Likewise, we calculate the segment 9, the length of segment 9xy. Here x is the center of the smallest semicircle with radius 5. Y is the center of the biggest semicircle with radius 15. The smallest semicircle and the biggest semicircle have an internal notch between them at this point, point A. And whenever we have an internal notch between two circles, then the distance between their centers will be equal to the difference between the lengths of the radii. The radius of the biggest circle is 15 units. The radius of the biggest semicircle is 15 units. The radius of this semicircle is 5 units, and the difference between the two radii, it is 15 minus 5, that is 10. So we found out that xy equals to 10 units. Likewise, we calculate the value of xz. Again, x is the center of this semicircle with radius 5. Z is the center of this semicircle with radius 10. Those two semicircles have an internal notch between them at this point. That is to say, they are touching each other internally at this point. Therefore, the distance between their centers will be equal to the sum of the length of the radii. That is to say, it will be equal to the radius of this semicircle, that is 5, times plus the radius of this semicircle, that is 10. And 5 plus 10 is 15. So in conclusion, we found out that CZ equals to 15 units. Okay, then I presented to you the law of cosines. That is true in any triangle. So if we have this triangle, triangle ABC, that could be any triangle. And we know that side AB equals to A units, side BC equals to B units in its length, side AC equals to C units. And the angle between side AB and side BC is theta. Then, according to the law of cosines, C squared equals to A squared plus B squared minus 2 times AB times cosine theta. Okay? And the Pythagoras theorem is a special case of the law of sines, of the law of cosines, this law, when theta is equal to 90 degrees. If theta equals to 90 degrees, then we are talking about a right triangle. And cosine 90 degrees is 0, so this expression minus 2ab times cosine theta will be equal to 0, and we left only with c squared equals to a squared plus b squared. And this is exactly the Pythagoras theorem that says that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay? So, in the next step, we'll copy triangle XCY in a new page, and we'll implement the law of cosines in this triangle CXY. So this is triangle CXY that I copied from the original drawing. We know that CX equals to R plus 5, XY equals to 10 units, CY equals to 15 minus R. So we implement the law of cosines in this triangle CXY according to the law of cosines. CY squared equals to CX squared plus XY squared minus 2 times CX times XY times cosine theta. Okay? CY is 15 minus R, so CY squared is 15 minus R squared, and it is equal to CX squared. CX is R plus 5, so CX squared is R plus 5 squared, and we also have okay, so here we got that CY squared equals to CX squared plus XY squared plus 2 times CX CY times cosine theta. CY is 15 minus R, so CY squared is 15 minus R squared. That is equal to CX squared. CX is R plus 5, so CX squared is R plus 5 squared. XY is 10, so XY squared is 10 squared, that is 100. Minus 2 times CX is R plus 5 times XY, that is 10 times cosine theta. Here we open the brackets on both sides of equation number 1, and we got that according to equation number 1, 15 minus R squared equals to 15 squared, that is 225, plus R squared minus 2 times 15 times R, that is minus 30R. And it is equal to R plus 5 squared. R plus 5 squared equals to R squared, R squared plus 5 squared, that is 25, plus 2 times R times 5, that is 10R, minus, here we have minus 5 minus 15 times minus 2 times 10 is minus 20 times R plus 5 times cosine theta. So here we have R squared on both sides of equation number 1, so R squared will get cancelled, and we left only with 225 minus 30R, that is equal to 125 plus 10R plus minus 2 times R plus 5 times cosine theta. So here we subtracted 125 from this equation. We subtracted 125 from equation number 1. 225 minus 125 is 100. And we also subtracted 10R from this equation number 1. And minus 30R minus 10R is minus 40R. So in conclusion, we found out that according to equation number 1, 100 minus 40R equals to minus 20 times r plus 5 times cosine theta. We multiply the equation number 1 by minus 1 and we got that 100 times minus 1 is minus 100. Minus 40r times minus 1 is plus 40r. And so in conclusion, we found out that 40r minus 100 equals to minus 20 times 100 is plus 20. So it is, in conclusion, we found out that 40r minus 100 equals to 20 times r plus 5 times cosine theta. Here we divided the equation number 1 by 20 times r plus 5. And we got that cosine theta equals to 40r minus 100 over 20 times r plus 5. Here we divided both the numerator and the denominator of this side of equation number 1 by 20. And we got that 40r over 20 is 12, and minus 100 over 20 is minus 5. 20 over 20 is 1. So in conclusion, we found out that according to equation number 1, cosine theta equals to 2r minus 5 over r plus 5. Okay? And we implemented, the next step, we implemented the law of cosines on triangle CXZ. So I copy triangle CXZ in this new page. And we implemented the law of cosines on this triangle, triangle CXZ. We have already known that CX equals to r plus 5, XZ equals to 15, and CZ equals to r plus 10. So according to the law of cosines, we will get that CZ squared equals to CX squared plus XZ squared minus 2 times CX times XZ times cosine theta. This is equation number 2. CZ is r plus 10, so CZ square is r plus 10 squared, and it equals to CX squared. CX is r plus 5, so CX squared is r plus 5 squared, plus XZ squared. XZ is 15, so XZ squared is 15 squared, that is 225. And we have, it is also minus 2 times CX XZ times cosine theta, that is minus 2 times CX is r plus 5, XZ is 15 times cosine theta. Okay? Here we open the brackets on both sides of equation number 2, and we got that r plus 10 squared equals to r squared plus 10 squared plus 2 times r times 10, that is 20r, and it is equal to r plus 5 squared, that is actually r squared plus 5 squared, that is 25, minus 2 times r times 5, that is plus 10r, minus 2 times r plus 5 times 15 times cosine theta. Here we have r squared on both sides of the equation, so r squared will get cancelled. And in this side of equation number 2, we have 100 plus 20r, that is equal to 225 plus 25 plus 10r minus 30 times r plus 5 times cosine theta. Here 225 plus 25 is 220. We have also plus 10r minus 30 times r plus 5 times cosine theta, and it is equal to 100 plus 20r. Here we subtracted 250 from equation number 2, and we got that 100 minus 250 is minus 150. Then we subtracted 10r from this equation, equation number 2, and we got that 20r minus 10r is 10r, and it is equal to minus 30 times r plus 5 times cosine theta. Here we multiply the equation number 2 by minus 1, and we got that minus 150 times minus 1 is plus 150, 10r minus 1 is minus 10r, and minus 30 times minus 1 is plus 30, so we will have 30 times r plus 5 times cosine theta. In conclusion, we have found out that according to equation number 2, 150 minus 10 r equals to 30 times r plus 5 times cosine theta. Here we divided equation number 2 by 30 times r plus 5, and we got that according to equation number 2, cosine theta equals to 150 minus 10r over 30 times r plus 5. So here we divided both the numerator and the denominator of this side of equation number 2 by 10, and we got that 150 over 10 is 15, minus 10r over 10 is minus r, and in the denominator we have 30 over 10 is 3, so in conclusion we found out that cosine theta according to equation number 2 equals to 15 minus r over 3 times r plus 5. But according to equation number 1, we have already found out that cosine theta equals to 2r minus 5 over r plus 5. Then we created equation number 3 that states that cosine theta according to equation number 1 must be equal to cosine theta according to equation number 2. So cosine theta according to equation number 1 is 2r minus 5 over r plus 5, and it must be equal to cosine theta according to equation number 2, that is 15 minus r over 3 times r plus 5. Okay? Here we multiply the equation number 3 by r plus 5, so r plus 5 will get cancelled in the denominator. Then we multiplied equation number 3 by 3, and we got that 3 times 2r minus 5 equals to 15 minus r. We open the brackets here, and we got that 3 times 2r is 6r, and 3 times minus 5 is minus 15. So in conclusion, we found out that according to equation number 3, 6r minus 15 equals to 15 minus r. We added r to this equation, and we also added 15 to this equation, and we got that 6r plus r is 7r, and 15 plus 15 is 30. So in conclusion, we found out that 7r equals to 30 according to equation number 3. We divided the equation number 3 by 7, and we got that the radius of the orange circle equals to 30 over 7 units. But we are looking for the diameter, and the diameter of any circle or semicircle is twice as large as the radius. So we multiply the radius by 2, and we got the diameter. In conclusion, we found out that the diameter of the orange circle is equal to 2r, and 2r is 2 times 30 over 7, because r equals to 30 over 7. 2 times 30 over 7 is 60 over 7 units. So in conclusion, we found out that the diameter of this orange circle equals to either 60 over 7 units, or in terms of numbers, it equals to 8.5714 units. Okay, so we finished with the first question. In the next step, we will solve the second question. Here in the drawing we have a quarter circle. Inside this quarter circle we have a square ABCO, and we also have angle AMB that is equal to 90 degrees, and we have angle BQC that is equal to theta, and that is the angle that we are looking for. And in order to find out the value of angle theta, we made a construction. But first of all, because we have here a quarter circle, OQ must be equal to the radius of the quarter circle. That is to say, we define the radius of the quarter circle as r, therefore OQ equals to r. OQ equals to r. That is the radius of the quarter circle. Okay, OQ equals to r, the radius of the quarter circle. Okay, so in order to find out the size of this angle, angle theta. We will make a construction. We will extend line segment MA by a straight line, and we will extend line segment QO also by a straight line until they intersect with each other. Okay. And we will define the intersection point between extended line segment MA and extended line segment BO as point N. In the next step, we will complete the quarter circle to a semicircle. So we build a semicircle from the quarter circle. This is a semicircle that we built from the quarter circle. Inside this quarter circle, we have the peripheral angle NMQ, that is right angle. It is equal to 90 degrees. And we also have rule number 1 that is related to a peripheral angle that is equal to 90 degrees. According to rule number 1, any peripheral angle that is equal to 90 degrees must rest on the diameter. I will read rule number 1 again. According to rule number 1, any peripheral angle that is equal to 90 degrees must rest on the diameter. So here we have peripheral angle NMQ that is equal to 90 degrees. Therefore, according to rule number 1, the peripheral angle NMQ that is equal to 90 degrees must rest on the diameter. And this angle NMQ rests on NQ. That is to say, according to rule number 1, NQ is the diameter of the semicircle. So according to rule number 1, we will conclude that NQ is the diameter of the semicircle. And we know that QO is the radius of the semicircle, that is equal to R. QO is equal to R. NQ as the diameter is twice as large as the radius, that is to say it will be equal to 2R. And what is the value of line segment ON? ON equals to QN minus QO. I will repeat again. From the drawing you can see that ON equals to QN minus QO. So actually we found out that ON equals to QN, that is 2R, this is the diameter, minus QO, that is the radius, that is R. ON equals to 2R minus R, that is R. ON equals to R. That is the radius of the semicircle and also the radius of the quarter circle. So we can write here that ON is equal to R. So we will focus on the right triangle, triangle NMQ. In the right triangle, triangle NMQ, we know that the sum of the angles must be equal to 180 degrees. So which angles we have inside triangle NMQ? We have here 90 degrees. We have also here angle theta. And we have this angle, this is angle MNQ. In total, the sum of those triangles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Okay, the sum of those triangles must be equal to 180 degrees. We will subtract 90 degrees from this equation and we will get that theta plus angle MNQ is equal to 180 degrees minus 90 degrees, it is 90 degrees. We'll subtract theta from this equation and we get that angle MNA, the angle that we are looking for, angle MNQ, angle MNQ is equal to 90 degrees minus theta. Angle MNQ equals to 90 degrees minus theta. So we can write down here that angle MNQ is equal to 90 degrees minus theta. Okay, and we also know that all the angles inside the square are right angles, therefore all the angles inside square ABCO are equal to 90 degrees, so we'll build there 4 right angles. Because of the fact that we have already found out that NQ is the diameter of the semicircle, therefore NQ must be a straight line. As a diameter, it must be a straight line. NQ must be a straight line because it is the diameter of the semicircle. I write it down. You can write down that NQ is a straight line. And we have rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. write it down. Is equal to 180 degrees. So I write rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. Okay? So here, if we focus on the upper side of the straight line NQ at point O, then the sum of the angles on the upper side of the straight line NQ at point O must be equal to 180 degrees according to rule number 2. So which angles we have at the upper side of NQ at point O? We have here 90 degrees. And we also have here angle AON. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. I repeat again. On the upper side of the straight line NQ at point O, the sum of the angles must be equal to 180 degrees according to rule number 2. So which angles we have at point O on the upper side of NQ? We have 90 degrees, and we have also angle AON. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. We will subtract 90 degrees from this equation, and we will get that the missing angle AON is equal to 180 degrees minus 90 degrees, it is 90 degrees. Okay, we found out that this angle is the right angle, it is equal to 90 degrees. This angle AON is equal to 90 degrees. Likewise, if you focus on the upper side of the straight line NQ at point C, then the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of NQ at point C? We have here 90 degrees. We have here also angle BCQ, this angle. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. I'll repeat again. On the upper side of the straight line NQ at point C, the sum of the angles must be equal to 180 degrees. Which angles we have at point C? We have 90 degrees, and we also have angle BCQ. And according to rule number 2, the sum of those two angles must be equal to 180 degrees. We will subtract 90 degrees from this equation, and we will get that the missing angle BCQ is equal to 180 degrees minus 90 degrees, it is 90 degrees. The missing angle BCQ is equal to 90 degrees. So this angle is the right angle, it is equal to 90 degrees. We will focus on this right triangle, triangle BCQ. In the right triangle, triangle BCQ, this right triangle, we know that the sum of the angles must be equal to 180 degrees. According to the rule that the sum of the angles in any triangle is equal to 180 degrees. So which angles we have in this right triangle? We have 90 degrees, and we have angle theta, and we have this angle that is angle CBQ. In total, the sum of those three angles must be equal to 180 degrees. Okay. I'll repeat again. In the right triangle BCQ, the sum of the angles must be equal to 180 degrees. So which angles we have in triangle BCQ? We have one angle that is a right angle, we have angle theta, we have angle CBQ. In total, the sum of those three angles must be equal to 180 degrees. We will subtract 90 degrees from this equation. And we'll get that theta plus angle CBQ is equal to 180 degrees minus 90 degrees, it is 90 degrees. Okay, we subtract theta from this equation, and we get that the missing angle CBQ is equal to 90 degrees minus theta. So we found out that this angle CBQ equals to 90 degrees minus theta. In the next step, we will focus on this right triangle, triangle AON. We will repeat on the same process, the right triangle AON. We know that the sum of the angles in the right triangle, triangle AON, must be equal to 180 degrees. So which angles we have? We have one angle that is equal to 90 degrees. We have also this angle that is equal to 90 degrees minus theta. And we have also this angle that is angle OAN. In total, the sum of those three angles must be equal to 180 degrees. The sum of the angles in triangle AON must be equal to 180 degrees. So here we have 90 degrees plus 90 degrees, it is 180 degrees. So we have 180 degrees on both sides of the equation. So 180 degrees will get cancelled. We left only with minus theta plus angle OAN equals to 0. We will add theta to this equation, and we will get that the missing angle OAN is equal to theta. The missing angle AON equals to, it is actually angle, yes, the missing angle OAN equals to theta. So we actually found out that all the angles of the right triangle AON can relate to all the angles of the right triangle, triangle BCQ. Why? Because both triangles have angle theta. Both those two triangles have angle that is equal to 90 degrees minus theta. And both those two triangles have angle that is a right angle that is equal to 90 degrees. Therefore, we will conclude that those two triangles are similar to each other according to angle similarity rule. So write it down. From the fact that all the angles of triangle AON can go into all the angles of triangle BCQ, we will conclude that the right triangle, triangle AON, is similar, this is the sign of similar, to the right triangle, triangle BCQ, and they are similar to each other according to angle similarity rule. Okay, so from the fact that those two triangles are similar to each other, we will conclude that the following relationship exists between their sides. We will conclude that QC or CQ, QC over OA, QC over OA equals to BC over NO. I repeat again, from the fact that triangle AON is similar to triangle BCQ, we will conclude that QC over OA equals to BC over ON. Okay? We'll find out the value of line segment QC. On the drawing, it is very easy to see that the value of line segment QC equals to QO minus OC. QO minus OC equals to QC. So actually, we found out that QC is equal to QO, that is R, minus OC. We define OC as A, so it is R minus A. QC equals to R minus A. So according to our definition, OC equals to A. And because of the fact that OC is one side of square ABCD, therefore all the other sides will be also equal to A. So AO will be also equal to A, AB also will be equal to A, and BC will be also equal to A because of the fact that all the sides of a square are equal to each other. Okay, so according to equation number 1, QC over OA equals to BC over NO. So QC, we found out that QC equals to R minus A, so we substitute QC by R minus A over OA. OA equals to A, and according to equation number 1, it is equal to BC. BC is also equals to A, BC over NO, and NO equals to R. So in conclusion, according to equation number 1, we found out that R minus A over A equals to A over R. Here we split this expression to two parts, and we get that according to equation number 1, R minus A over A equals to R over A minus A over A. Minus A over A is minus 1, and it is equal to A over R, according to equation number 1. I repeat again, according to equation number 1, we found out that R over A minus 1 equals to A over R. Okay, we'll focus on the right triangle, triangle AON. In this right triangle, triangle AON, we know that tangent theta equals to R over A. I repeat again, in the right triangle, triangle AON, tangent theta equals to A over R, so we can substitute tangent theta equals to R over A, so we can substitute R over A by tangent theta. We'll do it now. We'll substitute R over A in equation number 1 by tangent theta. We'll do it now, and we'll get that according to equation number 1, R over A is tangent theta, minus 1 equals to a over r, but a over r is 1 over r over a. Now we can substitute r over a in equation number 1 here by tangent theta. And we do it now and we get the tangent theta minus 1 equals to 1 over r over a is tangent theta. So we substitute r over a by tangent theta. So in conclusion, we found out that according to equation number 1, tangent theta minus 1 equals to 1 over tangent theta. We will multiply equation number 1 by tangent theta, and we will get that according to equation number 1, tangent theta times tangent theta is tangent square theta. Minus 1 times tangent theta is minus tangent theta. And it is equal to 1. Here we will subtract 1 from this equation, equation number 1. And we will get that according to equation number 1, tangent square theta minus tangent theta minus 1 equals to 0. Okay, so we got a quadratic equation. In this quadratic equation, the missing variable is tangent theta, and actually the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of a according to the following formula. We find out x is the variable that we are looking for, and we find out the value of x according to the following formula, that x is equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the coefficient a is equal to 1, the coefficient b is equal to minus 1, and the coefficient c is also equal to minus 1. And the missing variable, the variable that we are looking for is tangent theta, so x equals to tangent theta. So we put the data inside the equation for x in order to find out the value of the values of tangent theta. And we will get that according to this equation for x, the tangent theta, x equals to tangent theta, so it is tangent theta equals to minus b. B is minus 1, so minus b is minus 1, that is 1, plus minus square root of b squared. B is minus 1, so b squared is minus 1 squared, minus 1 squared is 1. Minus 4 times a is 1, times c is minus 1, over 2a. A is 1, so 2 times 1 is 2. So in conclusion, we found out that according to this equation for x, the tangent theta is equal to 1 plus minus. Minus 4 times minus 1 is 4, and 4 plus 1 is 5, so it is inside the root we have only 5 left over 2. So here we have two solutions that are possible for tangent theta. The first solution is that tangent theta is equal to 1 plus root of 5 over 2. And the second solution that is possible for tangent theta is the tangent theta is equal to 1 minus square root of 5 over 2. 1 minus square root of 5 over 2 is negative number, it is less than 0. And here, from the drawing, we can see that we have the right triangle, triangle NMQ. In this right triangle, triangle NMQ, we have angle 90 degrees minus theta. That is 1 out of 3 angles of a right triangle, therefore it is absolutely a positive number, or positive angle. So 90 degrees minus theta is greater than 0, we will add theta to this inequality, and we will get that 90 degrees is greater than theta from one side, but from the other side, in this right triangle NQ, we have this angle theta that is absolutely a positive angle. So theta from one side is greater than 0, and from the other side is less than 90 degrees. So theta is between 0 to 90 degrees, and in this range of angles, the function tangents is a positive number. So tangent theta is positive. We found out that tangent theta is positive, must be positive, while according to the second solution, we found out that tangent theta is a negative number. So we have here a contradiction, therefore this solution is incorrect solution. We'll cancel this solution, and we will have only the solution that tangent theta equals to 1 plus 4 to 5 over 2, and if tangent theta equals to 1 plus 4 to 5 over 2, then in order to find out the value of theta itself, we will operate the inverse function, the opposite function of tangents on the function tangents on the result, that is 1 plus 4 to 5 over 2. I'll repeat again, we will operate the opposite function on the result, that is 1 plus 4 to 5 over 2, in order to find out the value of theta itself. And we'll find out that the value of theta itself equals to 58.28 degrees. So we found out that angle theta itself equals to 58.28 degrees. Okay, the answer to the question is that angle theta, the angle that we are looking for, this angle is equal to 58.28 degrees. So in the next step, I will summarize the lecture. Actually, we wanted to find out the value of the size of this angle theta. Here we have here a quarter circle. Inside this quarter circle, we have square ABCO, and inside this quarter circle, we have also angle AMB that is equal to 90 degrees, and we have also this angle BQC that is equal to theta, and this is the angle that we are looking for. We want to find out the size of the value of angle theta. So in order to find out the value of angle theta, we made a construction. We extended line segment MA by straight line, and we extended line segment QO also by straight line until they intersect with each other. And we define the intersection point between extended MA and extended QO as N. Okay? And then we completed the quarter circle to a semicircle, and here we actually created the peripheral angle NMQ. NMQ is absolutely a peripheral angle that is located inside the semicircle, and this peripheral angle equals to 90 degrees. And we have rule number 1 that is related to peripheral angle that is equal to 90 degrees. According to rule number 1, any peripheral angle that is equal to 90 degrees must rest on the diameter. Therefore, according to rule number 1, the peripheral angle NMQ that is equal to 90 degrees must rest on the diameter. That is to say, and it rests on NQ. Therefore, NQ must be the diameter according to rule number 1. So we found out that NQ is the diameter of the semicircle. But because of the fact that this is a quarter circle, then OQ must be the radius of the quarter circle, and O must be the center of the circle or quarter circle or semicircle. Anyway, it is the center of the circle. Okay, but QO is the radius. So we define the radius of the quarter circle as R. So we found out that QO equals to R and Q equals to 2R. This is the diameter of the quarter circle. So what is the value of ON? ON is equal to NQ minus QO. Again, ON equals to QN minus QO. So ON is equal to QN, that is 2R, minus QO, that is R. So in conclusion, we found out that line segment ON equals to R. So ON is the radius of the circle and the quarter circle itself. And QO is also the radius of the circle and the semicircle itself. And in triangle, the right triangle, triangle NMQ, the sum of the angles must be equal to 180 degrees. So which angles we have here? We have here 90 degrees, we have angle theta, and we have angle MNQ. The sum of those three angles must be equal to 180 degrees in triangle NMQ, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. We subtracted 100 degrees from this equation, and we got that angle Q plus angle MNO must be equal to 180 degrees minus 90 degrees, it is 90 degrees. We subtracted angle theta from this equation and we found out that angle NMQ equals to 90 degrees minus theta. So we found out that this angle, the missing angle MNQ equals to 90 degrees minus theta. Then we already found out that NQ is the diameter of the semicircle. NQ as a diameter must be a straight line. Okay, NQ, it is a diameter, therefore it must be a straight line. NQ is a straight line, and we have rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, so if we focus on the upper side of the straight line NQ at point O, then the sum of the angles must be equal to 180 degrees according to rule number 2. So at point O, which angles we have here? We have here 90 degrees plus angle AON. In total, the sum of those two angles, 90 degrees plus angle AON, in total must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation, and we got that angle AON equals to 180 degrees minus 90 degrees, it is 90 degrees. So we found out that the missing angle, this angle AON equals to 90 degrees. Likewise, if we focus on the upper side of the straight line NQ at point C, then the sum of the angles here must be equal to 180 degrees. So which angles we have here? We have here 90 degrees, here 90 degrees plus angle BCQ. In total, the sum of those two angles must be equal to 180 degrees. I repeat again, 90 degrees plus the size of angle BCQ. In total, they must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation and found out that the missing angle BCQ equals to 90 degrees. So this angle is the right angle, it is equal to 90 degrees. Then we focus on the right triangle BCQ. In the right triangle BCQ, the sum of the angles must be equal to 180 degrees. So which angles we have here? We have here angle theta plus angle that is equal to 90 degrees plus this angle that is angle CBQ. In total, the sum of those three angles must be equal to 180 degrees. So here, in the right triangle BCQ, the sum of the angles equals to 90 degrees. This is to say 90 degrees plus angle theta plus the size of angle CBQ. In total, they must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we got that angle theta plus angle CBQ equals to 180 degrees minus 90 degrees, it is 90 degrees. We subtracted theta from this equation, and we found out that the missing angle CBQ equals to 90 degrees minus theta. So here, we can write down that this angle equals to 90 degrees minus theta. Likewise, we did the same process in the right triangle AON. In the right triangle AON, the sum of the angles must be equal to 180 degrees. So which angles we have in the right triangle AON? We have one angle that is 90 degrees minus theta, we have one angle that is 90 degrees, and we have this angle, the missing angle, that is angle OAN. In total, the sum of three angles, the sum of those three angles must be equal to 180 degrees. Okay, so here, 90 degrees, the size of the first angle plus the size of the second angle that is 90 degrees minus theta plus the size of the fourth angle that is angle OAN. In total, the sum of those three angles must be equal to 180 degrees. We have 90 degrees plus 90 degrees, that is 180 degrees in this side of the equation, and we have 180 degrees on the other side of the equation. So 180 degrees will get cancelled, and we got that minus theta plus angle OAN equals to 0. We added theta to this equation, and we found out that the missing angle AON equals to theta. So this angle, the missing angle, equals to theta. We actually found out that all the angles of triangle BCQ can go into all the angles of triangle AON. Both those triangles have angle theta, both those two triangles have angle that is 90 degrees minus theta, and both those two triangles have angle that is equal to 90 degrees. Therefore, we can conclude from it that the right triangle AON is similar to the right triangle BCQ. I'll repeat again. Therefore, the right triangle AON is similar to the right triangle BCQ according to angle similarity rule. And from the fact that those two triangles are similar to each other, we will conclude that the following relationship exists between their sides. That is to say, we will conclude that QC over OA equals to BC over ON. I'll repeat again. QC over OA equals to BC over ON. What is the value of QC? QC equals to QO minus OC. QC equals to QO minus OC. So QO equals to R. OC equals to A according to our definition. So in conclusion, we found out that QC equals to R minus A. So we can substitute QC in equation number 1 by R minus A. We did it. And we got that QC that is equal to R minus A, over OA is A, BC is A, and ON is N. So in conclusion, we found out that according to equation number 1, R minus A over A equals to A over R. Okay, then we focused on the right triangle AON. In the right triangle AON. But before that, we split the expression R minus A over A to two parts. R minus A over A equals to R over A minus A over A. And minus A over A is minus 1. So in conclusion, we got equation number 1 that says that R over A minus 1 equals to A over R. Then we focused on the right triangle AON. In this right triangle AON, tangent theta equals to R over A. Tangent theta equals to R over A, so we can substitute R over A in equation number 1 by tangent theta. We did it, and we got that R over A is tangent theta minus 1 equals to 1, and A over R is 1 over R over A. Now we can substitute R over A by tangent theta. So we did it, and we got that tangent theta minus 1 equals to 1 over R over A is tangent theta. So we substituted R over A by tangent theta. Then we multiplied the equation number 1 by tangent theta, and we got that tangent theta squared minus theta equals to 1. We subtracted 1 from equation number 1, and we found out that tangent squared theta minus tangent theta minus 1 equals to 0. And here we have a quadratic equation. The missing variable is tangent theta, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. A, B, and C are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to the following formula, that x is equal to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the coefficient a is 1, the coefficient b is minus 1, the coefficient c is also minus 1, and the variable that we are looking for is tangent theta. So x equals to tangent theta. So we put the data inside the formula for x, and we found out the value of tangents, the values of tangent theta. Here tangent theta equals to minus b. B is minus 1, so minus b is minus 1, that is plus 1. Plus minus square root of b squared minus 4 times ac. B is minus 1, b squared is minus 1 squared, this is 1. Minus 4 times a is 1, c is minus 1. So minus 4 times minus 1 is 4. So inside the root we have 4 plus 1, that is 5. So in conclusion we found out that tangent theta equals to 1 plus minus square root of 5 over 2. So here we will have two solutions that are possible for tangent theta. The first solution is tangent theta equals to 1 plus square root of 5 over 2. And the second solution for tangent theta is that tangent theta equals to 1 minus square root of 5 over 2. That is a negative number. But here we can see this right triangle, triangle NMQ. This angle QNM is equal to 90 degrees minus theta, and it is absolutely a positive angle. So we can write down that 90 degrees minus theta, it is a positive number. 90 degrees minus theta, it is greater than 0. From the drawing you can see it from one side, but from the other side, likewise, we can see in this same right triangle that angle theta, this is angle theta, and this angle theta is a positive angle. So we can write down that angle theta itself is greater than 0. So from one side angle theta is less than 90 degrees, and from the other side it is greater than 0. And in this range of angles, between angle 0 to 90 degrees, the function tangents is a positive. So, and we are in the range of angles between 0 to 90 degrees, and between those ranges of angles, tangent theta is a positive. So actually we can conclude that tangent theta must be a positive number, but according to this solution, tangent theta is less than 0. It is a negative number. So we have here a contradiction. Therefore this solution is the incorrect solution. We cancel this solution and we left only with the solution that tangent theta equals to 1 plus square root of 5 over 2. So if tangent theta equals to 1 plus square root of 5 over 2, we will operate the opposite side, the opposite function of tangents on the result, and we will find out the value of theta itself. So the inverse tangents, the opposite function of tangents, we operated it on the result, that is 1 plus square root of 5 over 2, and the inverse function, the inverse tangents of 1 plus square root of 5 over 2 is 58.28 degrees. So we found out that tangent theta is equal to 58.28 degrees. Again, the answer to this question is that tangent theta is that angle theta, the angle that we are looking for, it is equal to 58.28 degrees. Okay? The value of angle theta, or the size of angle theta, is equal to 58.28 degrees. Okay? Thank you very much.